All right, let's talk about computers. Not just the one in front of you, but the entire spectrum of them, from the device that fits in your pocket to the absolute monsters that can predict the future. We're going to cover it all. You know, it's pretty wild when you stop and think about it. Your phone has more power than all of NASA did back in 1969. But there's a whole other universe of computing out there. So, how does your pocket-sized supercomputer stack up against the real giants? Well, that's what we're here to find out. So here's how we're going to tackle this. We'll start small at the personal level that we all know and love. Then we're going to scale up to the machines that run businesses and universities. After that, we go global to the biggest machines on the planet. And finally, we'll take a quick look back to see how we even got here in the first place.
Okay, first up, the personal scale. This is home base for pretty much all of us. And this entire world, everything you use day to day, it's all built on one revolutionary concept: the microcomputer. So what makes it a microcomputer? Well, it all boils down to the microprocessor. This was the absolute game changer. It took the entire brain of the computer, the CPU, and squeezed it onto a single, tiny silicon chip. That's the breakthrough that took computers from filling entire rooms to sitting right on your desk. And that one little idea, it led to, well, all of this. Your desktop rig, your laptop for work, the tablet you're watching this on, the smartphone in your pocket, even your PS5 or Xbox, they all share that same DNA. At their core, they are all microcomputers, designed for you, a single user. All right, let's jump up a level. We're moving from a computer for one person to machines built to serve hundreds or even thousands of people at the same time. This is the organizational scale. Now, before we had our modern microcomputers, there was this really important stepping stone, the minicomputer. It was kind of the middle child of its day. Not as massive or expensive as the giants, the mainframes, which meant smaller companies and research labs could finally get in on the computing action. You don't really hear the term minicomputer anymore, and that's because its job was basically taken over by what we now just call servers. These are the powerful computers working behind the scenes, hosting websites, storing our data, and running networks. They're the direct descendants of what the minicomputer was designed to do. But then you have jobs that are just too big, even for a powerful server. And that's where the mainframe still reigns supreme. Now, don't picture some dusty old museum piece. A modern mainframe is a data processing beast. Its superpower isn't solving one complex problem. It's handling millions and millions of simple things like transactions all at once without breaking a sweat. So why are these things still the heart of global banking, airlines, and retail? It comes down to these three pillars, often just called RAS. They have rock-solid reliability, they have insane availability, meaning they basically never go down, and they're designed for easy serviceability. These machines are engineered from the ground up to never, ever fail. Just to give you a sense of scale here, a modern mainframe can chew through 1 trillion secure transactions in a single day. Think about that. Every time you hit an ATM, book a flight, or just swipe your credit card, chances are you're talking to a mainframe. They are the invisible, ultra-reliable engines of our economy. Okay, it's time to go to the top, the absolute peak of the computing pyramid. We are now entering the world of the supercomputer. These are machines built to tackle calculations so massive they can literally simulate reality. And here's the most important difference. A supercomputer is all about calculation. We call it number crunching. So while a mainframe is a master juggler, handling millions of separate tasks, a supercomputer pours every last ounce of its power into solving one single, ridiculously complex problem. And what kind of problems are we talking about? Well, huge ones, like predicting the exact path of a hurricane, simulating the explosion of a star, designing the next generation of spacecraft, or modeling the future of our planet's climate. These are the kinds of grand challenges that demand this insane level of horsepower. You know, there's this great saying that really captures the spirit of all of this. It's a reminder that what seems like science fiction today is just standard issue tomorrow. The technologies being invented right now for these supercomputers will eventually find their way into the device you're holding. So let's put this all together, because this comparison is so important. A mainframe is like a huge, busy airport. It's all about managing thousands of arrivals and departures. Its performance is measured in transactions, or MIPS. But a supercomputer? That's like a dedicated physics lab trying to crack a single monumental equation.
Its power is measured in complex calculations, or flops. It's volume versus complexity.
Okay, we've seen the what, the different types of computers. But how did we get from room-sized giants to pocket-sized powerhouses? Well, it was a journey made possible by a few fundamental leaps in technology.
You can really see the whole story unfold here. We started with enormous, fragile vacuum tubes. They were replaced by small, sturdy transistors. Then we figured out how to cram tons of transistors onto integrated circuits. And bam, the minicomputer was born. The fourth generation gave us the microcomputer, the whole brain on one chip, and with it, the personal computer. And now we're here, in the fifth generation, where it's all about AI and processing things in parallel.
And that really brings us full circle, doesn't it? Every time the hardware got smaller and faster, it didn't just improve what we had, it created entirely new types of computers. It allowed us to build the right machine for the right job, whether that job is sending a GIF, running a bank, or simulating the cosmos.
So I'll leave you with this final thought. As more and more of our computing moves into the cloud, and as we get closer to the dawn of quantum computing, are these categories we've talked about even going to matter anymore? Is the whole idea of scale about to be completely redefined? That's a question for the next chapter of this story. Something to think about.